انا نفضيها اصلا. طب شفتها بتاعها؟ اوكي. Titrometric methods of analysis. Based on the measurement of the amount of reagent that combined was analyzed, we have many techniques here. Volumetric volume of reagent solution required for a complete reaction, gravimetric weight of reagent required for a complete reaction, and colorimetric, which is time current required for complete visual reduction of an analyte. In volumetric titrometric, this method requires that a reagent solution of normal concentration be used, which is called the standard solution for titrant. Example here the determination of chloride. We have here chlorine ion in aqueous plus silver ion aqueous. Through titration to reduce silver chloride. Analyte unknown concentration here and titrant here is silver nitrate, a standard solution for non-concentration. In volumetric titrometry, we use burettes. By accurately measuring the volume of titrant that is added, the amount of sample can be determined. A burette is used to control and measure the amount of titrant that is added. The point where sufficient, which is called equivalent point or end point, this is the point where sufficient titrant has been added to be stoichiometrically equivalent to the amount of analyte. Just enough titrant has been added to react with all of our catalysts or with all of our analyte. For example, determination of chlorine or chloride, 50 milliliter of 0.1 molar solution of silver nitrate solution would be required to completely react with 0.005 moles of chloride. The end point. What is the difference between equivalent point and end point here? The volume of titrant required for detection of an equivalent point. Ideally, we want two equivalence point and end point to be the same. So the succeed here is end point be equivalent to equivalent point. The seldom happen due to the method used to observe endpoint. Results in titration error called over-titration. Indicators. This indicator is very important factor here for titration reaction. What's indicators? Some sort of approach must be used so that endpoint can be observed. How would you observe the endpoint? How would you catch the endpoint? One common method is to have our titrant react with a secondary chemical after reacting with our analyte. Then the chemical will undergo a change that can be detected, like a change in color, like a change in voltage, something like that. Endpoint here, the endpoint is then the point where sufficient indicator has been converted for detection. So analyte plus titrant, a stoichiometric addition gives equivalent point. So the indicator with titrant has color, but the reacted indicator after finishing the reaction has another color. By changing the color between the two cases, we can know and catch the end point of the reaction. This last step does not require that all indicators be converted, but if only a small percent need to be reacted to make the change visible. Here we can see in this graph the end point. The left hand side here, the color is white, and the right hand side here, the color is white. The changing color means the endpoint is gone. Primary standard. We have two sorts of standards, primary standard, secondary standard. Sometimes we have third standard. In primary standards, our titrant solution must be of no composition and concentration. Ideally, we would like to start with primary standard material. But primary standard material, high purity compounds used to prepare our standard solution or to standardize solution with. Design properties of primary standard, high purity material, stable in air and solution, not hygroscopic, inexpensive, large formula weight, soluble in our solvent, react rapidly and similarly with our analyte. It's so difficult to catch it. These few materials have all these properties. So, primary standard solutions is stable in bottle may not remain that way in solution. A primary standard solution should have long-term ability in your solvent, react rapidly with your analyte, react completely with your analyte, be selective for your analyte. The last requirement is often based on the procedure used. So we have to go to secondary standard because first primary standard is impossible to get it. And if you get it, it will be costly and very expensive. So we have to deal with second standard, maybe less in accuracy than primary standard, but it's easy to deal with and it gives you not bad results. In second standard, suitable primary standard are not always